we're going to talk about the layer 2 technologies that pertain to the CCIE lab. So when it comes to the layer 2 technologies in the lab, what you need to know is, of course, Cisco's HDLC. You need to know PPP. You need to know frame relay. You need to know switching and related topics. So here, anything to do with Catalyst 3560. We need to know about spanning tree, VTP, DTP, ether channels, etc. And finally, PPP OE. So these are the layer 2 topics that I'm going to focus on, and of course we are going to talk about related stuff when we talk about, for example, QoS. I'll talk about the switching QoS when we talk about the QoS itself. This also applies to the frame relay, because I really don't want to water down the QoS and spread it, you know, a little bit here, a little bit there, a little bit there. I like to talk about QoS in a dedicated QoS section. So this is what we're going to go through now. So the first thing is really Cisco's HDLC. Now, the only important thing to remember about HDLC is that it's default on all serial interfaces. It's by default, so if you don't set encapsulation on the serial interface, it will be HDLC. If you want to change it, you of course have to use the encapsulation. But the big thing about Cisco HDLC is that it is default on all serial interfaces. So default on serial, and more importantly, it's default on all dialer interfaces. Now, you might be thinking, why do I care about the dialer interfaces? It's 2013. We are no longer using dial-up. Well, when it comes to PPPoE, that does use the dialer interfaces on the client side. If you don't set the encapsulation manually to PPP on the dialer interface, you are going to try to run HDLC over Ethernet, and that is not going to be very successful because there is no such thing. So remember this thing. This is the only big thing about HDLC that you will have in the lab. Now, given that it is so simple and it requires no configuration, it is the default on all the interfaces, it is very unlikely that the serial interfaces you will have in the lab will require you to run HDLC. What's going to be more likely scenario is that you will be configuring PPP on them. Now, when it comes to PPP in the CCIE lab, it used to be a very big topic. It's not a big topic anymore, but it's a carrier for other technologies. What I mean by that is that with PPP configured, they can test you, do you understand AAA? And with that, they can test you, do you understand radios, do you understand TACACs? They can test you about, for example, IPCP, which means that they can test you, do you understand what are the local pools, how they operate? They can test you on DHCP, especially if combined with PPP over Ethernet. They can test you different authentication methods. Do you understand PAP, CHAP, MS-CHAP, MS-CHAP version 2, and EAP. So all these things can be tested using PPP. And this is what's going to be difficult part about PPP in the lab. It's not going to be configuring things like link quality monitoring or configuring reliable links or configuring multi-link PPP interleaving. Yeah, all those things might be there, but that's not going to be the big thing. The big thing is the ability of PPP to actually be carrier for these other technologies. I like to think of PPP tasks when you encounter them in the lab. I like to think of them as of onions, right? Onions consist of multiple layers. So you have the core layer deep inside the root of the onion. Basically, that's in terms of PPP, that would be the connection between A and B, right? This is what we need to get. And then we pile the stuff on top that is just, you know, cosmetics, but it might be important in the lab. So this is exactly how I'm going to approach PPP now. I'm going to give you a sample task. So I'm going to type it out and we're going to see and go through this task and solve it together. And here I'm going to go on little tangents and explain related technologies. So that's what we're going to be doing. So let me first show you the network that we are going to work on. It's going to be a very, very complicated, very complex network setup. We are going to have two routers. This is going to be R7. This is going to be R8. This is going to be serial interface 000. This is going to be serial 000. And we want to run PPP between these two. The addressing scheme here is going to be 192.168.78.0/24. And throughout this week, this is going to be the addressing that I'm always going to be using. It's going to be 192.168, then device number. So if I'm using 7 and 8, it will be 78. If it's 1 and 2, it will be 12. 0/24, because really I don't want to bother with more complicated, complex addressing the subnets. It's not the purpose of this class. So here we are going to have .7, and here we are going to have .8. So seemingly simple network setup, but we are going to overcomplicate it a little bit. What we're going to do is we're going to have a task, and I'm just going to type it out here. So let's say, a little bit too big. Let's say that configure PPP between R7 and R8. R7 should authenticate R8 using CHAP R8's username. Let me just move this a little bit. Here. So R8's username should be router -8 and password IP expert. Let me add quotes here as well. And password IP expert. R7 should use tacax @server, tacax server at 1111 with the key IP expert. And if tacax is not available, use local case insensitive database for authentication. Now let's see R8. R8 should authenticate R7 using, let's say, let's use EAP. No, actually, let's use MSCHAP. Nah, PAP. I'll go over those other examples later on. PAP. R8 should authenticate R7 using PAP. R7's username should be router-7 and password IP expert. R8 should use radius server at 2222 key IP expert, standard port numbers, and if radius is not available, use local case sensitive database for authentication. Only a single radius packet should be sent per authentication request, and response should arrive within 3 seconds before declaring radius as unreachable. Finally, R8, or let's make R8 the complicated one. R8 should assign R7 IP address R7.7 using the local pool R7-pool using IPCP. So this is the task, and as you can see, it involves a lot of work. And PPP is going to be by far the simplest part here. The more complicated part is going to be configuring all these authentication, the fallbacks, and the AAA, and so on. And what you can expect from this task is to be 3 pointers. So this is 3 points, really 4 if you are very lucky, but this is most likely just a 3-point task. So what I suggest you do now is take a screenshot or something of this task, because I'm going to most likely cover up this with my terminal, and you won't be able to see the task. What I'm going to do for myself, I'm just going to copy this task to a text editor somewhere, so that I have a copy of it on screen that I can reference while I'm working on it. And you should do pretty much the same thing somehow now. So the next thing that I'm going to do is I'm going to bring up my terminal here. So let me just bring up R7 and R8. Here they are, R7 and R8. I don't have any configuration on my R7 and R8. The only configuration that I have there is the host name has been set. So I'm just going to set now the terminal length, terminal width, just so that the paging works properly. And I'm going to start configuring this task. So what we have here is configure PPP between R7 and R8. The first thing that I need to do here is basically get this link up and running. That's the foundation. Without this link up and running, none of it makes sense. So the first thing that I'm going to do, and I always use the text editor for this purpose, I'm just going to configure and make sure that my interfaces are up. So here I'm just going to say no shutdown. So configure terminal interface and no shutdown. So this goes here, this goes here. Now, the reason why I'm doing this, very basic, and this will be HTLC encapsulated, is I want to see that this link is actually operational. I want to see the CDP neighbors here. So on R7, I can see R8 as the neighbor. So I'm going to go to R8 and see if R8 actually sees R7 as the neighbor. Not yet, and if you are patient as I am, and I am very patient for very short periods of time, you can set the CDP timer to be a little bit shorter. So now every 5 seconds we should be sending something, in R8 should be seeing it by now. Okay, there we go. So now I can tell that R7 and R8 can actually communicate. So this eliminates the problems of, is the link up and running? Is it operational? Is the serial cable plugged in? And also, one thing that I'm going to do, even though this contradicts the task a little bit, I'm actually going to configure my IP addresses manually there. So 192.168.78.7. So this goes on R7, and this goes on R8. I'm just going to quickly correct it. And I'm going to make sure that from R8 I can ping R7, and that from R7 I can ping R8. So this is now operational. I can tell that this link is running. And this is where I'm actually going to stop working on the task, because I want to show you one thing. Now, you have probably seen this multiple times. So if I do show IP route connected at this point, on R7 for example, I'm going to see that I have 192.168.78.0/24 directly connected on the serial interface. So what I'm seeing here is the /24 route, the whatever I was configuring on the interface, is what I'm seeing as the directly connected route. On R8, I'm seeing the exact same thing. So here I configured /24 network, and here I am seeing /24 as directly connected route. So what I'm going to do next is I'm going to go and change this interface to be the point-to-point interface. So no other change, I'm not configuring any authentication, nothing of the sort. And I can see in the log message there that the line protocol went down. This is when we changed, so HDLC goes down and the line protocol changes state to up. Keep in mind that the physical interface is up all the time. So now we are running PPP. If I do show IP route connected now, I will be seeing two routes. One is the route that we had before, our /24 route, and the other one is /32 for our neighbor. This is the default behavior of PPP in iOS. You will always get /32 route for your neighbor. The same thing we have on R8. If I do show IP route connected, this is what I'm getting now. So this was what I had before with HDLC, and this is what I have now with PPP. Sometimes in the lab, and this is not the case in our task here, so I have not asked for this to be done, but sometimes in the lab they will ask you a question in which they say make sure that interfaces are advertised in the routing table or present in the routing table only with the correct masks. Now this is the exact shot at this behavior of PPP. This is the default behavior, but it can be changed. The command to change this is, and let's do it on R7, is PPP, no peer neighbor route. So when I enter this command, no peer neighbor route, what I'm going to see, and only after I bounce the interface, so now I'm not going to see it. I need to bring the interface down and bring it back up. So let's do shutdown, wait for the interface to go down, then do no shutdown. So now if I do show IP route connected, I'm going to see that only /24 route is present in my routing table. So again, at this point, I should be able to ping R8, and from R8, I should be able to ping R7, and this works correctly. So if you are asked in a PPP task to not have that /32, and they could ask you in the task explicitly, or they could have a global requirement that all interfaces are present in the routing tables with the correct masks, this is what you need to do. But be on the lookout. If it's a global requirement, they could mean one other thing, and I will talk about it later on. It's unrelated to PPP, it's related to some other technologies, that they could ask you to have that. Now, the question that I have there is why /32? Well, in a case of IPv6, you will get /128, I believe. The reason is you are getting the host route for the neighbor, and /32 is the host route. So you're basically telling this router the peer's address is this. So you're getting the route to the host that you are directly connected to. Now, it makes very little sense in this scenario that we are dealing with. So in this case here, it makes very, very little sense. But when you think about the scenarios in which PPP is also used, like back in early days of internet, like for example for dial-up, it made perfect sense because you had on the dial-in side, you had a virtual template that needed to be cloned multiple times. But each virtual access interface that got cloned had a different peer on the other side on the same /24 subnet, for example. So we needed a way to tell the routers what is their peer on the other side. The same thing we have with PPPoE. So with PPPoE, this is absolutely crucial behavior. So does that answer the question you had? Okay, still not seeing the response to that, so I'm just going to go with yes. So that's the reason why you're getting the host route, so that in some scenarios you can reach the other side. As I say, in the example that we are having in front of us right here, it is not necessary to do this, right? This /32 gives us no benefit, so we may as well get rid of it. But my advice to you is never configure something in the lab just because. You either need to have it or the lab asked for it. If you do it just because, you could end up in a trouble. So now I'm going to leave this and I'm going to show you rather quickly how you can end up in trouble with this, just configuring it when no one actually asked us to configure. So basically we now have the connectivity between R7 and R8. So this is only a partially done now. We have actually not solved any part of this traffic other than configure PPP between R7 and R8. Now, here I'm faced with choice. What should I do next? Should I configure the authentication? Should I do the IPCP or something? But whenever I have a task that is like this, like the onion task, what I like to have is I like to have a safe position. I like to be in a position that no matter what I do, if I mess something up, I can always take one step back and have an operational technology, have an operational link in this case. Now, I could theoretically go into my notepad and I could type out the configs for all of this stuff. I could paste them in, and then when something doesn't work, where do I begin? Is it the TACAX? Is it the radios? Is it the AAA? Is it the IPCP that is broken? What did I mess up? I am going to try to avoid this situation as much as I can for any technology that I'm configuring. So always take one step at a time. Now, at first, it may appear as if you are losing a lot of time doing that you are not moving as fast as you should, that you are not moving as fast as you could. But as you will notice, the speed loss is going to be very minimal. But the confidence that you are going to be building up, that your configurations are correct, and the built-in verification in this process is invaluable in the lab, because you will know when you're done with the task, you are done with the task because you have tested it all the way and you know it works. And if something doesn't work, you can always take a step back and you say, okay, I'm sacrificing these 3 points for PPP, but let's say OSPF that is going to be running over this link for 3 points, I'm not going to lose those points. But if your link is down, you're not going to get OSPF points, you're not going to get multicast points because they don't work. If the task said run OSPF over this link and if there is no neighbor, they don't care that the link is not down, they care that OSPF doesn't work. So sometimes in the lab you might be faced with, position where you need to sacrifice the points. And if you need to do that, sacrifice just 3 points. Don't sacrifice 15. That would be a terrible thing to do. So with that in mind, I'm going to take it one step at a time. So now I have operational PPP link. Now I know that authentication is a relatively involved process, especially in this case where I need to enable AAA. So I'm just going to focus on solving the IPCP part. So here it says that R8 should assign R7's IP address .7 using the local pool R7 pool. So I'm going to go to my R8, and the first thing that I'm going to do is I'm going to define the local pool, and I'm going to call it R7-pool. And here the next parameter is going to be the first IP address in the range. So what should be my first IP address in the range? Well, it's R7's address. And here it says enter the last IP address of the range, or simply press enter. Well, that's exactly what I need. I need pool of IP addresses for R7, and R7 needs to use one address. So I'm creating a pool of a single address. This is pointless, but this is what the lab asked me to do. Sometimes in the lab, you must not ask the question, why would I do this? The answer is simple, because the lab asked for it. Now, if the lab simply said, use IPCP to assign R7's address from R8, I wouldn't be using the local pool. I would be using a different method, which I'm going to show you in a second. I'm not going to configure, just going to show it to you, because it's happening in the same spot where I need to go next anyways. So the next stage is I need to go to the interface, so interface serial 000, and here I'm going to say peer default IP address, and here I have the parameter where I could actually enter the IP address of the peer, but this is not what the lab asked me to do. The lab told me that I need to use the pool, so here I have the option to use the pool, and I'm going to specify the name of the pool, R7-pool. This is now finished configuration on R8. Let's go to R7. So this is the current configuration of the interface on R7. And here we have statically configured IP address. This is not what I need. What I need is negotiated IP address. So I'm going to shut the interface now. And I'm going to enable do debug PPP negotiations. So I'm going to enable the debugging of PPP negotiations and going to say no shutdown here. And of course now when the interface comes up, we're going to get a lot of output. And the important thing here that we are getting is that we are installing the negotiated IP address 192.168.78.7. That's good. So if I go to R8 now, if I do show IP route connected, this is what I'm seeing. I'm seeing the peers route, I'm seeing the /24. If I go to R7, and if I do show IP route connected, take a look at what I'm seeing. I'm seeing just 192.168.78.7, my own IP address. Now, take a look at this. It says the mask is /32. If you are using IPCP, this is what you get by default, which means that right now we don't have IP connectivity between R7 and R8. If I try to ping R7, meaning if I try to ping myself, that is going to work. If I try to ping R8, that is not going to work. Now, the reason for this is we caused the problem. This was our configuration that actually caused this. So if I take a look at the running config of the interface, see this? Sorry, this? No peer neighbor route. Now, R7 doesn't know how to reach R8. The only information it has is the installed IP address from the peer. The peer never told it what should be the subnet mask. Well, good news there is, and whenever you have good news, sometimes you have bad news. The good news there is that we actually do have an option to request the mask in IPCP. If I go to R8 and here say peer, PPP IPCP mask 255.255.255.0. So now this is the configuration on the interface on R8. I'm telling it if anybody asks for a subnet mask, send this mask. And on R7, this is what I'm telling it, request the mask. Now, if I do shutdown and no shutdown, and keep in mind our PPP debug is still ongoing, so I'm going to do the no shutdown now. Please observe the debugs. I will highlight the important bits. Here it says we are installing this negotiated IP address, and this is the subnet address, and this is the mask. Well, there is a problem with this. Take a look at this. We still have only /32. If I do show interface serial 000, this is the IP address. So we can clearly see here that PPP negotiated the mask and then iOS completely and utterly ignored it. This is the reason why you shouldn't just simply configure the stuff because you think it's the right thing to do. We are causing our problem with this command here that no one asked us to do. Now, we know there is a way to negotiate the mask, but we also know that it won't work. Not at least in this version of iOS, and to be honest, I was never able to make this work. So this is the problem. So at this point, we actually have to put this back in. We actually need the neighbor route right now. So the point to take out of this is if you are asked to use IPCP, do not use no peer neighbor route because it will cause you connectivity issues. So right now, I'm just going to say no shutdown. And again, negotiation. Again, we are going to get that bogus information about the mask. And if I do show IP route now, at this point, I still don't have the correct mask, but now I will have reachability because now I actually do have the neighbor's address here. So I can ping R8 from R7. I can also ping myself. I can ping myself from R8 and I can ping R7 from R8. So this is an important thing about IPCP that I wanted to mention. There is one more thing now. Keep in mind that from R7's perspective, this is a /32 interface address. That means that if you are running an IP protocol that will check for masks in routing updates, and which is pretty much the ANY protocol, you might have problems if you try to run it on this link. Now, for OSPF, this will not be a problem because OSPF on point-to-point links will ignore whatever the mask is set. EIGRP will be fine, RIP will struggle. So if you want to run RIP between R7 and R8, you might need to do something extra. So even though I will talk about RIP in a little bit more detail later on today, this is something that I want to show you right now. So what I'm going to do now on R7 and R8, I'm just quickly going to add one loopback interface. Actually, I'm just going to do it on R8 because that's really where it's important. So I'm just going to add the loopback, and I'm going to run RIP very, very quickly. So version 2, no auto summary, and I'm just going to enable it on all the interfaces. So this is the configuration for R8. So this goes in here, and on R7, actually let me add the loopback there as well. It will be more obvious. So this is going to go on R7. So now I have RIP configured on R7, and the updates should be sent. So if I go to R8 and if I do say show IP route RIP, I'm seeing the loopback interface of R7. So that routing update from R7 arrived to R8 and there were no problems with it. On R7 side, if I do show IP route RIP, there is nothing in the routing table. Now, what's the reason for that? Well, let's remove the debug that we have going on now, and let's run debug IP RIP events. So let's wait for the routing update to arrive from R8. Now, given my luck, because the routing updates are sent every 30 seconds, we are probably going to be waiting for 29 seconds, but I was a little bit luckier than that, because here is the error message. It says, we have ignored version 2 update from a bad source, 192.168.78.8. Why is this a bad source? Well, if you take a look at show IP route connected, is this IP address on the same subnet as our own interface? The answer is no, because our interface is /32. This is direct adjacency, but it is not on the same subnet as our interface. So we are saying we are receiving a routing update from a router that is not on the same subnet as we are. And this is going to be rejected by RIP by default. In order to address this, in order to fix this, we need to go to router RIP and say no validate update source. When we enter this command, and this is a global, so this applies to all interfaces running RIP on R7 now, what we are telling R7 is, even if you receive an update, a RIP update from an interface, from a source IP address that is not your own, accept it, because that is okay. And sometimes you just need to do this, and this is one of the cases. And the only reason why we have to do this now is because we are running IPCP. So show IP route RIP, now we actually have the route in the routing table. Now, I was a little bit worried because I wasn't getting the debug message, but I forgot completely that I actually turned off the debug here. So I was having a mild panic in my head. Why is there no routing update coming in? But it did arrive. So here now we have addressed this issue. At this point, we are now at a situation that we do have IPCP functional, so this part here is done correctly. We also have PPP running, so at this point now, we should really go on and do the authentication. Just like the advice that I've given you before, in which I said, okay, take it easy, one step at a time, I'm going to do the same thing with authentication. PPP authentication can be configured even without using the AAA. So I don't need AAA. All I need to do is configure the usernames and passwords on two sides, and I can check if my CHAP and PAP operate correctly. Now, here I'm going to talk a little bit about PPP authentication. So when you have two routers that are configured for PPP authentication, it's important to remember that authentication is in PPP always unidirectional. So for this direction of authentication, so let's say here that we have R1 and here we have R2. For the purpose of PPP authentication, this is the server and this is the client. We are saying that the client is authenticating to the server. In other words, the server is authenticating the client. I'm saying this because on the server is where you need to say PPP authenticate. This is a server-side configuration. On the client, you do not need to configure this. Actually, if you do configure it, you are now requesting R2 to authenticate back to R1. Now, you can have that situation as well, like this, in which case this becomes server and this becomes the client. For this situation, for the authentication in this direction, you might need, not might need, but you do need PPP authenticate. But these are two separate processes. We have one that is happening here on the left-hand side, and we have one that is happening here on the right-hand side, the green and the red one. Now, it is important to remember that these are independent from each other, but like everything in networking and everything in iOS, and iOS is very consistent in its inconsistency, this is true as long as you are not running PAP and CHAP. Now, when you're running PAP and CHAP, there is slight relationship between these two. And the relationship is, if for example here we are running PAP and here we are running CHAP, or the other way around, the passwords need to match. So if you are running PAP and CHAP, password must be the same. Any other combination, it's okay to have a different password for the green authentication and a different password for the red authentication. So this is just one of those caveats there that you need to be on the lookout. But I do see that there is a question there, so let me just take a look. The question is about the previous example here. There was no need to assign an IP address on the interfaces to begin with. Absolutely no need. It was an unnecessary step. But what I was doing with that step is I was verifying that IP connectivity actually works. So that when I go into something that is a little bit unusual, something a little bit out of ordinary, I know that it is not going to be my configuration that is causing it, or that it will be my configuration causing it either way, because I have tested it. If I put IP addresses manually, it pings. Now imagine that you didn't do that step and you went through that IPCP scenario and suddenly from R7 you cannot ping R8. Oh, you're going to go very crazy and start troubleshooting what's going on, what did I do wrong, why doesn't this work? But if you take a look that if you put IP addresses manually, it works. If you use IPCP, it doesn't work. You know it's the IPCP config. There is something wrong with it, so it pushes you in the right direction. So this is the only reason why I've done it. And if you can't figure out what the reason is, you can always take a step back, put the IP addresses back on the interface, and you have a fully operational interface. So that's the only reason why I did it. It was an unnecessary step, but in line with my suggestion to always have a safe fallback, this is why I did it. It's important to remember that it is unidirectional, but when you are using PAP and CHAP as the combination, there is this slight little relationship between them that you cannot use different passwords for different directions. For any other combination, you can do it. So going back to our task here, it says R7 should authenticate R8 using CHAP. So we can conclude from this here that for this stuff here, R7 is the server and R8 is the client. For the other case where R8 should authenticate R7, here, this is the server and R7 is the client. So we have to configure bidirectional authentication using different protocols, with different routers being the servers and clients. So let's go ahead and do that. I'm going to start with the first step, that R7 should authenticate R8 using CHAP. So I'm going to go back to my terminal here and actually need my text editor as well. I always do everything in text editor. It makes it so faster to do. So I'm just going to move it here to be a little bit out of the way. So what I'm going to do here now is I'm going to define the username for router 8. So it's going to be username router 8, password, IP expert. Then I'm going to say interface serial 000. I'm going to say PPP authentication, and I already forgot R7 should use CHAP, so I'm going to say PPP authentication CHAP. So this should be the configuration on R7. So when I paste this in, what I should be seeing now is the line protocol changing state to down. Okay, let's do the configuration on R8. On R8 side, we need to respond to the challenge from R8. So here I'm going to say PPP CHAP hostname router-8. This is entirely optional line. If, for example, I was using username R8, I wouldn't have to do this line because whatever is configured as the host name on the device will be sent as the username for CHAP authentication. But in this case, we are using a different string. And here I'm going to say PPP CHAP password, and I'm going to say IP expert. So here I'm going to paste it in, and my interface should be changing state to up. And it doesn't. It doesn't because I have misconfigured something. I have deliberately made a mistake in my configuration. So this is the configuration on the interface on R7. And this is the configuration of the username on R7. So we have username router8 password IP expert, and here we are requesting the CHAP authentication. On R8, we are responding to this authentication with username and password. But our interface, if I go back to R7, is still up down. And if I enable debug PPP authentication, what I should be seeing here is that the authentication is actually failing. And we can see here that we are sending, let me turn off the debug so I can go this line by line. So we are sending the challenge from R7, we are receiving the response from router 8, so we know that router 8 is responding here correctly. We are sending the login request, and we are receiving the login that fails, and we are sending that, hey look, you have failed the authentication. Now, the mistake that I made here was deliberate, as I say, but it's very, very, very easy to make it. The mistake is in this line here. Password 0 simply means that whatever follows here is the plain text password. Alternative to this would be password 7, which means that encrypted password will follow. The problem is with this part here. Now, you cannot see it because it's nothing on nothing. If I do show run include IP expert immediately followed by the end of the line, this here is a regular expression that says I'm trying to match IP expert that is right at the end of the line. I'm going to get 0 lines. But now, take a look at this. There is actually a space after the password. Now, depending on your terminal, when you highlight it, you might see it or might not. My terminal actually does it, but if you do it just a little bit longer, you're going to highlight the whole line. So you need to be very, very careful. As I said, I have deliberately made this mistake. So when I typed out my configurations in my editor here, when I was typing username, router 8, password, IP expert, I have actually put the space and then pressed enter. But take a look at this. So now I'm going to say username Marco, password, IP expert, IP expert. Okay, I don't need anything else, so I'm just going to press enter. What happened here is that I typed IP expert space, I pressed the question mark, saw that this is it, and pressed enter. Which means that what actually ends up in the running configuration is my username with password IP expert space. It is incredibly easy to make this mistake. So here is the piece of advice. Whenever you need to type the password or the key in the iOS, I cannot remember a command where this will not be the very last thing on the command line. So don't type the question mark after the password, because the space that you enter there will be part of the password. Now, an extreme example of this would be, for example, this thing here. Take a look at this configuration now. Oops, sorry. It says username Marco, password IP expert privilege 15. What do you think is the privilege level of this user? The privilege level is 1. The password is this. So this is the password for user Marco. And the privilege is unchanged because this privilege 15 is not part of the command line. This is part of the password string. So what we have here is, if I wanted to configure user Marco with privilege 15, I would have to use username Marco, privilege 15, password, IP expert. Now it's correct thing. And also this would be an interesting thing in the troubleshooting section, that they could configure it like this when it's twisted it around, you cannot log in, and your privilege doesn't work. So you need to figure out that it is actually the order of these keywords that is causing the problem. So now that we have identified what the problem with my PPP was, I'm just going to repaste this configuration back in to see if my interface comes up. And take a look, the interface actually changed state to up. Actually, the line protocol on the interface changed state to up. So now we are up and running. How do you verify that your PPP authentication worked? Well, obviously you can run the debugs, but that's not a very effective way. The easiest way to do that is to run who command from the exec or do who from the config, which is the equivalent of show users command, which will show you that on interface serial 000, we have a user router-8 logged in using synchronous PPP. Now, important thing to remember here is that once the user is successfully authenticated, iOS does not maintain information how this user was authenticated. So there is no way to tell using show commands whether this was PAP or CHAP, was the radius used or the TACAX or the local database or the whatever else we might have. So that information is actually destroyed by iOS. It's not kept in the iOS. If you are using accounting part of the AAA, this information might be sent in the accounting packet to the TACAX or the radius, but in the iOS itself, there is no information how the user was authenticated, which is good news because it means that we can actually configure the other side as well. And we have satisfied the requirements of these two tasks, and configuring radius and TACAX is just pretend only. Because if our authentication works, they would actually, for grading purposes, they would actually have to go in there, shut the interfaces down, do no shutdown, and observe the behavior, which is a big warning for you. Make sure that your later configurations in the lab can actually handle this. Don't rely on, okay, it works now, but if they shut this interface down, something might break in my network. Assume that they will be shutting interfaces down. Warning number 2. Your routers and switches will not be rebooted before the grading. They're going to grade them as is. So don't rely that something will be rebooted and that reboot will actually fix the issues you might have. That won't happen. But your interfaces might be bounced as the part of the grading process. So let's now configure the authentication in the other direction. So on R8 side, I'm going to say username, router-7, password, IP expert. This time I'm not going to press space. And then I'm going to go to the interface. So interface serial 000. And here I'm going to say PPP authentication PAP. So now R8 is going to be requesting R7 to authenticate to it. When I enter this command, the line protocol on serial 000 is going to change state to down, because now I actually need to configure R7 as the client. For this, the command is ppp pap send username router-7 password IP expert. So this is the configuration that will go on R7. So this goes in, and when I enter this command, the line protocol should change state to up, which it just did. And on R8, I'm going to say show users, and I can see now that on interface serial 000 router-7 is logged in using synchronous PPP. So this now worked. So it's a good position to save the configs, because at this point now we are going to start working on AAA.